Okay, Pick Computing A-Level Computing Video 90. Again, looking at operating system, and this time interrupts. It's worth just mentioning again that if you find some of the things in this video difficult to understand, and often these concepts are, then if you can't get your head around them, the thing to do is just to memorize the definitions and learn the definitions, and you can still pick up lots of marks in an exam. Okay, interrupts. If we can understand how interrupts work in an operating system, we need to understand how the operating system manages the processor. The vast majority of operating systems handle serial processing, and serial processing is where one instruction is fetched, is then decoded, and then executed, and then a second instruction will be fetched, and then that second one decoded, and the second one executed, i.e. it will just handle one instruction at a time. Therefore it is serial. It does things in a sequential order, but just one at a time. Some, and very few, operating systems will handle parallel processing, where one instruction might be fetched whilst another one is being decoded, another one might be decoded whilst another one is executed, and so on and so forth. This is called parallel processing because more than one thing happens at the same time in the processor. But like I say, most operating systems don't have this. Most have serial processing. And understanding that is key to understanding why we need this thing called interrupts. Interrupts are where the processor needs to stop what it is doing and do something else instead. For example, the primary memory over here on the right to secondary storage on the right, the buffer in between is empty and needs refilling so that data transfer between the two pieces of hardware can continue. The interrupt is a thing that asks for this sort of thing to happen, so the current job being stopped and temporarily replaced by another one. Interrupts can come in very quickly, so each one is given a priority based on its importance. So the operating system knows if one interrupt needs to stop for another interrupt. So how does this all work? If you can remember this, you'll be doing well. All jobs are stored in order of priority. When the processor finishes executing an instruction, it checks the list of remaining jobs. If the job it is currently doing is still at the top of the list, it will continue to do this job, and it will do the next instruction in that job. However, if that job isn't still at the top of the list, it will start doing the new high priority job that is at the top of the list, but not before storing the job it was previously doing in a register. And this is done to avoid wasting processing that's already been done. That stands to reason. If there are multiple interrupted jobs that need storing for later, they are stored in something called a stack in a register, and we'll look at stacks in more detail in a future video. Now, hopefully this flowchart will explain interrupt handling a little bit better. So if you still haven't got your head around it, just pause the video here and see if this can help. One last slide is on the different types of interrupts that can happen. There are input-output interrupts, which are generated by input-output devices to say whether data transfer has finished maybe, or has there been an error maybe. There are timer interrupts, and these are generated by the internal clock of the computer to say that a time-critical activity needs attention. There are hardware interrupts, which are generated by pieces of hardware, such as the power supply sending a signal to say that there might be power failure, and that one is actually the highest priority of an interrupt that there can be, so that the operating system can try and close down gracefully before all power is gone. And there are software interrupts, which are generated by programs. An example of that might be if a program tries to divide something by 0, which is impossible, then an interrupt would be sent to the processor to say, hey, handle this division by 0 error for me. So that's interrupts in a nutshell for you. I hope you can get something from that. Have a look at that flowchart again if it helps, and bye for now.